So for example 3, here's what I'm going to do. I'm just going to go over it orally, and then you should be able to write down the explanation of how to prove that angle JLK is congruent to angle MLN. Okay, but here's angle JLK. I want to try to prove that that's congruent to triangle MLN. If you look at the tick marks by what's given, okay, angle J is congruent to angle M. JK, that side is congruent to MN, and I'm not kidding. Get it? JK? Never mind. And then lastly, side JL is congruent to side ML. So then these two triangles, JKL and MNL, are congruent specifically by side angle side. Since the triangles are congruent, all their corresponding parts are congruent. Angle JLK and angle MLN are corresponding angles. Therefore, they are congruent by specifically CPCTC. Again, you could also prove that angle K is congruent to angle N for the same reason, but that's not what was being asked. Now, in this last example, I'm actually just going to go over part B. It says write a proof to verify that the method you described in part A is valid. We actually want to figure out how the surveyor can find the width of the river, or side BA in this case. Okay, so here's what's given. Angle A is a right angle. Angle D is a right angle on this figure right here. Side AC is congruent to side CD. So I'm going to start setting up a 2-column proof for that. So just to save a little bit of time, I wrote down the statements, the first 2 statements and the first 2 reasons, what were given. Okay, and then we need to figure out how we can prove that these 2 triangles are congruent. Because if they're congruent, the surveyor doesn't want to have to take a tape measure or a rope or something from point A, one side of the river, all the way to point B on the other side of the river. If they can figure out and measure the length of DE, since it's basically on the dry side of the river, then that would be the same as the length of AB. So one thing that we could say is the vertical angles are congruent. So the vertical angles are marked in the diagram. Those are angles BCA and angle DCE. Those are congruent. And I know some people might say, well, okay, then the 2 triangles are congruent, specifically by angle, side angle, and they are, but you actually need another step before that. Maybe you put it as a second step instead of number 4. So sometimes, as I mentioned before, the order could be a little bit different, but you should say something like this. Angle A is congruent to angle D. The reason why they're congruent is they're right angles, or I'm pretty sure we went over before that all right angles are congruent. I might have also gone over before the acronym, all right angles are congruent. Okay, if you don't know that acronym, you don't remember it, then just write out each of the words. But now these 2 triangles are congruent specifically by angle, side angle. Maybe a common mistake would be trying to use hypotenuse leg because these 2 triangles are right triangles. And that's not a bad thought, but just because 2 triangles are right triangles doesn't necessarily mean that you would always prove that the triangles are congruent by hypotenuse leg. And then here's an example of when you wouldn't do that. But if the 2 triangles are congruent, as I mentioned, side AB is congruent to side DE, specifically because they're corresponding parts. We proved that the triangles are congruent, and by CPCTC, these 2 corresponding sides are congruent. That's the proof, but then as I mentioned, the surveyor could measure the side length of DE, maybe with a tape measure or whatever this device is. I think that can measure distances besides having to go across the river and then measuring the length of the river. But that's the 2-column proof for that specific example.